See, this is your thought process. You'd say the area of a full circle is pi r squared. Agreed?
Yes.
But now we only want a certain section of the full circle. So the section we want is 120 over 360. Does everybody see? Pi r squared. So it's 120 over 360, and then pi, and then our radius squared, 5 centimeters squared. Everybody listen, on the test, I want the mathematician answer, and I want the engineer answer, but I really, especially want the mathematician answer. So if your calculator is one of those weird ones that's not converting very good, you would need to kind of do it in sections. So this simplifies to be 1/3. 1/3 times pi times 5 squared. So you'd say 5 squared is 25. 1/3 times pi times 25. So your answer you would give me on the test is 25 pi thirds. And then that's square centimeters. A centimeter and times a centimeter is square centimeters. That doesn't change anything. I'm just getting you used to seeing some, what are they called? Units of measure. Wait, is that what it was called? Okay, great. And then I also want the engineer answer, how many actual square centimeters?
6.18.
Okay, awesome. Centimeters squared. Okay, any questions on that? How many got it right? Good. Hopefully the homework went okay for you last time, did it?
Yeah.
Okay, awesome. Now, once again, remember, you're not going, oh, I hate unit circle, oh, I don't like trig, because you might change your mind this year. It's actually, if you don't like the unit circle, you weren't taught correctly. It's easy. So, give it another chance. Let's start over. Here we go. Okay. So, guys, consider the unit circle, but understanding this stuff is important. So, focus. Consider the unit circle given by this equation. X squared plus y squared equals 1. Just a reminder, the equation to a circle in general is x squared plus y squared equals radius squared. So I've literally taken x squared plus y squared equals 1, and I've drawn it right here on this xy chart. Notice we have a center at 0, 0, and a radius of 1. Does everybody see?
Yes.
Over 1, up 1, over 1, down 1. Okay, now pretend like I took, here's the x-axis, here's the real number line, okay? Pretend I took this starting here and on forever this way, and I just started wrapping it around this radius of 1. Wrapping it around forever. It's like, and wrapping around forever. Does everybody see what I'm doing?
Yes.
Now I'm taking the negatives and I'm just wrapping it around as well. So the negative numbers are wrapped around. That is literally what the unit circle is. So now picture me wrapping that stuff around and then going boom, 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 and zooming in, and I'm looking at this. Does everybody see? I just zoomed in on this. Picture yourself going for your oh. You guys see me? Okay, all right. Now that makes sense. Look, if this was 0, 0, our origin, then wouldn't this point be over 1 up 0? This would be over 0 up 1. This would be over negative 1 up 0, and over 0 down 1. I've just zoomed in. Yeah, just zoomed in so it's bigger. Awesome. Okay. Well, guys, that is what the unit circle is. Now, isn't it true if I took and wrapped the real number line around, right here are all my real numbers, right? Isn't it true that as the real number line is wrapped around this circle here, each number here will correspond to some xy point. Right here at this number, aren't I at some xy point? Some x, some y, some x, some y point. And I could, everywhere I go, it will correspond to some xy point. Now also, isn't it true that on the real number line as I wrap around, at any xy point, it's also going to create an angle theta. Central angle theta. So we have a bunch of right triangles in here that we can draw. Does everybody see? Okay, write this down and then I'm going to show you where it comes from. If we are dealing with this, understand this, only if we are dealing with the unit circle. If and only if we have a radius of 1, we can assume these trig functions will always be true. Then we'll talk about why. The sine of an angle, sine of angle theta, will always be the y value of an xy point. Always. Sine will always be the y value. We'll talk about why in a second. Cosine of any angle will always be x, the x value on the xy point, and tangent of theta will always be the y value divided by the x value. Every time. Now that is only true, though, if we have a radius of 1, aka the unit circle. Now cosecant of theta, cosecant is the reciprocal of sine. So cosecant is just reciprocate y over 1, and we get 1 over y. Just reciprocating the answer for sine. Does everybody see? And then secant is the reciprocal of cosine. Notice S and C's go together. S and C, just so you know. Secant is the reciprocal of cosine, so it would be 1 over x. And cotangent is the reciprocal of tangent, so that would be the x value divided by the y value. So it is going to be really easy to do trig on the unit circle because we know these 3 things. Well, 6 things technically. So once you have them written down, we're going to explain why we can always assume that sine of any angle will be y, period, end of story, every time. Okay. Let's look at, here's my unit circle, I've zoomed in, and let's focus in on this xy point right here. I'm going around the real number line, and I've decided to stop at this xy point. Now I drop straight down, and I have this right triangle with this being a distance of x, some x amount, right? And this being a distance of some y amount. Now this is a right triangle, and we know our right triangle trig ratios. So it is true that sine of theta is opposite over hypotenuse, cosine of theta is adjacent over hypotenuse, and tangent of theta is opposite over adjacent. Those are right triangle trig ratios. Now, however you remember that is good. So, toa. I go sine, cosine, tangent, and then I say the saying, oh heck, another hour of agony. Or whatever. However you remember it, as long as you can do it. Now, if and only if we are dealing with the unit circle, and we are, isn't it true that from here to here, our radius is 1 no matter where we draw it? So from here to here, we have a radius of 1. All right, well, let's perform sine of that angle then on a unit circle. Sine of theta is opposite, which is y, over the hypotenuse, which is 1. Therefore, we can always know on the unit circle, because our hypotenuse will always be 1, sine of theta will always be just y, because y divided by 1 is y. Does everybody see? So that's why sine of theta is just y. Yes?
The bottom numbers should be 0.
Yes, it should. Good catch. 0, -1. Good catch. Okay, let's go on to cosine. So cosine of theta would be our adjacent side. Our adjacent side from theta is x. And our hypotenuse on the unit circle is always 1. That's why we can always say that cosine of theta is always just x on our unit circle. And then tangent of theta is our opposite side, which will be y, divided by our adjacent side, which would be x. That's why on the unit circle, tangent is always the y value divided by the x value. Does that make sense? And the reciprocals fall accordingly. Yeah? Okay. What if the radius isn't 1? Then we're not talking unit circle trig. And you can't just say sine is y. You have to do, oh heck, does everybody see? The radius is 1, aka the unit circle, is the only time we can say sine is just a y value. Okay. Alright, so now, oh yeah, okay, well why do we have this, well what does the unit circle allow us to do now? Now think about this. If we only knew right triangle trigonometry, oh heck, another hour of agony, isn't it true that all angles in right triangles have to be acute?
Yes.
Well, there are angles that are not acute, and we still need to be able to do trig on those angles, right? So what the unit circle does is it allows us to now do trig on obtuse angles. Do you guys see what I'm saying? All right, also, so on non-right triangles, basically. And then also, isn't it true that in right triangles, we always have positive angles? Well, now, we have negative angles in real life. We need to be able to do trig on negative angles. And now we can, because we have a unit circle. We can now extend this to negative angles and angles equal to 90 or greater than 90, which is nice. Because now we can do trig on a lot more than just right triangles. Does that make sense? Okay. All right, so the unit circle I need you to understand is just showing us commonly used angles and these special exact points, xy points, that go at these angles here. Now yes, there are way more angles than just 30, 45, 60. Look, I could draw 5, 10, 15, 20, you guys see that. But they don't have a special xy point with these exact answers. So we just, where do these special things come from? Why do we choose 30, 45, 60? Why do we have these special points? Yes, and, most importantly, they are special right triangles, everybody. So, let's write down. Let's first focus in on 45 degrees, everybody. Because you might be wondering, well, why do you get this XY point? I'm about to show you. Now, you might be asked on the test why, so this would probably be a good thing to really focus in on. So if I start here at 0, and I start going around the new number line, the real number line, and I stop here at 45 degrees. I have an angle theta of 45 degrees, and I can drop down and create a right triangle. Does everybody see? Okay, now, 45, 90, 45. 45, 45, 90. 45, 45, 90. These are special right triangles. This pattern will always happen. If this side's 7, this side must be 7 since they're both across from a 45 degree angle, correct? If we did the Pythagorean theorem, we would find that the hypotenuse is 7 root 2. So that relationship will always happen with a 45, 45, 90 degree triangle. Now we know because we're dealing with the unit circle, our radius is 1. So I've taken this and drawn it right here just to do some math. So let's figure out what this isn't this from here to here my x value, and from here to here my y value. Do you agree? So let's go ahead and do some math to figure out what these are. Now we know for a fact, I'm going to not change this, I'm not going to write that as y. Isn't this the same side length as this? If they're 45 and 45, they must be. So I'm going to call this x and this, well, I'll just go with a so people aren't like, well, you said x and y. Okay, so I'm going to say, if this is side length a, this is also side length a. So now let's set up a true statement. Isn't it true that this side squared plus this side squared should equal our hypotenuse squared?
Yes.
A squared plus a squared equals 1 squared. Now how many a squareds do we have? So we have 2a squared equals 1. Solve for a. Divide by 2. Square root it. So a is equal to the square root of 1/2. Well, we probably should split that up. So isn't that the square root of 1? Square root of 1 over square root of 2, which rationalizes to be, that's not an appropriate answer. Good, we'd multiply by root 2 at root 2, so then on top we'd get root 2, and on bottom we'd get 2. We just solve for a. A is root 2 over 2. Well, then this side is also root 2 over 2. Well, there we go. X, y. That is why this xy point is root 2 over 2, root 2 over 2. Does everybody see? It's just a distance. Okay. Now you're not going to want to have to recreate this every time. I'm going to give you another way of kind of memorizing how to fill this in, but I'm just showing you where it comes from. Like why it's root 2 over 2. Algebraically. Okay. Let's now look at, instead of 30 degree special right triangle, 30, 60, 90. So now if we take and we start on the real number line and we stop at 30 degrees here, we have an xy point. Now x is this distance, y is this distance, and we have a hypotenuse of 1 since it's the unit circle. Just showing you a 30, 60, 90 special triangle will always have this relationship. So if we have a side length of 15, the hypotenuse, okay, across from the smallest angle 30 is a side length 15. The hypotenuse will always be double that, so that's 30. And then the side across from the 60 will always be this side root 3. So this relationship always exists with the 30, 60, 90 degree triangle. And you guys got into that in more detail in Sec 2. I'm just quickly showing you where these values come from. So I've taken this triangle right here, and I've drawn it right here. So guys, if my hypotenuse is 1, across from the 30 degrees should be half that amount. Do you agree? So 1/2. And now what's the relationship to the other side of 60? 1/2 root 3. So isn't that root 3 over 2? Do you guys see? So the x value would be root 3 over 2 in distance. The y value would be 1/2 in distance. Does that make sense? Now for 60, all I do is now take and rotate this. You guys see I'm just rotating the right triangle. It's still a 30, 60, 90, isn't it? And so wouldn't just our x, y points, notice they're just flipped. We're just rotating it. All right. I just kind of wanted to give you some background of where it comes from algebraically. Now I'm going to teach you how to fill in your unit circle. Oh, not yet, sorry. Okay, I want to show you how this works. We actually love the unit circle. It makes our life so easy. If you have a filled out unit circle, you can do right triangle trig 10 times quicker. You can literally look at your unit circle and answer it. So everybody, we know since it's a unit circle, Sine is the y value, cosine is the x value, and tangent is the y over x. So if this says find the sine at 60 degrees, that literally reads find the y value at 60 degrees. Does everybody see? So I go to 60 degrees. What is our y value? Root 3 over 2. So our answer is root 3 over 2. Trig is not hard. On the unit circle, it's easy. You guys see how easy that was? Okay. Now, it says find the cosine at 240 degrees. That literally says find the x value at 240 degrees. Negative 1/2. Very good. And then tangent at negative 30 degrees. So here's positive 30. So going negative 30 would put me here. You would say, well, tangent is the y value divided by the x value. So let's do some quick math. Our y value is negative 1/2 divided by our x value, root 3 over 2. Dividing fractions is easy as pie. We would flip the second and multiply. So times by 2 over root 3. Don't my 2's divide out? So I have negative 1 over root 3. So rationalize our denominator, root 3, root 3. So don't I get negative root 3 over 3? Okay, so right here, our tangent, see it's not written, but I'm just going to write it off to the side. We know it's root 3 over 3, and because we had a positive and negative, it would be negative. Positive divided by a negative is negative. Does everybody see? Now we're going to use that in the future. No? These? I haven't taught you that yet. That's what I'm going to teach you next. So don't you fret. I'm just giving this to you right now. So I'm just showing you how it works right now. But then I'm going to teach you from start to end how to fill this in, and you're going to see it's actually really easy. Okay, everybody, I just need you to see though. Do you see how, okay, so we're going to keep, okay, let's just go start filling this out so people aren't fretting. Okay, everybody, blank in a circle, grab it. Let me show you how I think through filling it out. I don't care if you don't think the way I do. If you can fill out a blank in a circle, that's all I care about. You will be tested. Let me push my watch because it's kind of a nice little thing, little tricks I show you. Okay, first of all, what I would do is fill in all the degrees. So I go through and fill out the easy degrees. So obviously 0 degrees, correct? And also 360 degrees. Now from there, I know halfway around a circle is 180 degrees. Agreed? We know that up here would be 90 degrees. So now think about it. You went 90 degrees, you added 90, 180, add 90 again. Don't you get 270? And now we're back to here. Now from there, you'd say, well, what degrees do these come from? Well, there are special right triangles, which are the 30, 60, 45. Does everybody see? So obviously this would be 30 degrees. This would be 45, and this would be 60. Now guys, just think in distances. Like think in distances. Look, from here to here was 30 degrees. Well, that's true. From here to here is a distance of 30 degrees. Now, isn't it 30 degrees less? So that would be 150. Another pattern to notice is, look, we add 30 degrees, add 15 degrees, add 15 degrees, add 30. Add 30, add 15, add 15, add 30. So you can just go through and fill it in. So you guys see the pattern? So right here, add 30, and we get add 15. Add 15, add 30. And then same thing, add 30, add 15, add 15, add 30, and done. Not done, but done to there. Okay. Add 30, add 15, add 15, and then add 30. So the degrees fill in really nicely. Now people tend to have a harder time with radians, but don't. Watch. Think of what a radian means. A radian means a physical distance of an arc, correct? Yes. Now, yes, once you know quadrant 1, you can fill in the rest. So watch. If you need to know what is the physical distance of this arc, remember how we convert degrees to radians. We'll only have to do this one time. 30 degrees times by pi over 180 would convert it to its radian length. Do you agree? Which is pi 6th in length. So from here to here, look, that distance is pi 6th in length. Do you guys understand that? Now look, that distance from here to here is 1 pi 6. Going that same amount of distance, wouldn't that put me here? It's got to stay the same length, right? So right here is 2, I'll write it up here, 2 pi 6, which is pi thirds. Let's keep going with that distance. Now that's another distance right here. So this is 1 pi 6, 2 pi 6, 3 pi 6. Yep, 3 pi 6, sorry. Which is pi halves. Oh, that one would have been easier just to fill in the radians here. Okay. Alright, well, okay. First of all, I'm going to fill in 0 and 2 pi. Isn't this a pi, obviously, everybody? Then obviously this was pi halves, because it's cut into fourths. So this is 1 pi halves, 2 pi halves, so this would be 3 pi halves. I should have filled those in first. Okay, awesome. Now back to the pi 6 thing, sorry. 1 pi 6, 2 pi 6, 3 pi 6, then wouldn't this be 4 pi 6?
Yes.
Which is 2 pi thirds. Okay, that was 4 pi 6, so this must be 5 pi 6 in length. Then look, 6 pi 6. We're doing good. Doesn't 6 pi 6 become pi? So then that same distance right here must be 7 pi 6. Now right here, 8 pi 6, which is 4 pi thirds. 9 pi 6, we're good. Keep going. 10, right here. 10 pi 6, 5 pi thirds. And then 11 pi 6. And then make sure you end up in the right spot. 12 pi 6. And that would be 2 pi. So do you guys see how that filled it in pretty nicely? And now we'll just do our pi fourths. Now, what a pi well, if you didn't know it was pi fourths, you would go off to the side and go 45 degrees times by pi over 180, and that is pi fourths. Do you agree? So the distance, look from here to here, this distance was 1 pi fourths. Wasn't that a big chunk, little chunk? To give us pi fourths in length. So go that same distance, big chunk, little chunk, 2 pi fourths, which is pi halves, big chunk, little chunk, 3 pi fourths in length, big chunk, little chunk, 4 pi fourths, we're doing good, then big chunk, little chunk, 5 pi fourths, big chunk, little chunk, 6 pi fourths, we already filled that in, big chunk, little chunk, 7 pi fourths, big chunk, little chunk, 8 pi fourths, which is 2 pi. And now we filled in the radians. Just think in distances and it's pretty straightforward. Now the points I give another really nice trick for, so if I would watch, first of all, let's fill in the obvious points. So everybody, from here to here we went over 1 unit of 0, correct? You gotta make sure you fill in these correctly. Over 0, up 1, over -1 of 0, over 0, down 1 unit. Is everybody good with that? Now this is my trick, okay? This is a pattern I've noticed, and this is just a trick I use. However you fill it in though, as long as you can do it correctly. All we have to do is fill in quadrant 1, and then we're good to go with the rest. So watch what I think through. So I literally just start counting up. It's always divided by 2. If you look on the unit circle, we always have a divide by 2 on bottom, everybody. So I start here and just start counting up, starting at 0. Look at my y values. I'm going to fill in my y values. So I think of this as square root of 0 over 2. Then this y value will be square root of 1 over 2, counting up. Square root of 2 over 2, counting up. Square root of 3 over 2, counting up. Square root of 4 over 2. Now look, simplify what can be simplified. Isn't square root of 0 over 2 0? Isn't square root of 4 over 2 2 over 2, which is 1. You guys see how I filled those in? Yes. And then obviously square root of 1 over 2 is just 1/2. So now I'm going to rewrite it in its simplified form, 1/2. Now just do that again. Look, start at 0 and count up. Square root of 0 over 2. Square root of 1 over 2, which is 1/2. Square root of 2 over 2. Square root of 3 over 2. Then square root of 4 over 2. That's how I fill it in. Now guys, if you can fill in quadrant 1, you can fill in any quadrant. Literally take this and stamp it across. Stamp. The points will match up. Up 30 degrees will have the same point. So it'll be root 3 over 2, 1/2. I'll come fill in the signs later, the correct signs. Middle, we'll go with middle. Root 2 over 2, root 2 over 2. Top, so that would be 1/2, root 3 over 2. Now isn't it true, to get to this physical point, I'm going negative x, positive y. Change my x's to be negative. And then guys, it just stamps this point and this point would match up. Root 3 over 2, 1/2. Root 2 over 2. Root 2 over 2. And then 1/2 root 3 over 2. They just stamp across. And then you'd say negative x, negative y to get to that point right there. So negative, 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 negative. And then I'm taking and just stamping across, or stamping across. So same thing, you'd say this point and this point are the same. Root 3 over 2, 1/2. Root 2 over 2, root 2 over 2. And then 1/2 root 3 over 2. And then you'd say, but to get to those points, positive x, negative y. So negative y, negative y, negative y. Questions on how to fill that out? Okay, in a second I'm just going to give you tons of time to just practice filling it out from start to end a few times, because you have blank ones. One more thing that will be really useful, you guys, here's the thing, in calculus, you will literally have to be able to say this quickly, at 30 degrees, start trying to memorize what the xy point is, so that it's quick. So just start trying, because your calculus teacher will make you have to know all of those within like 2 seconds. Like if she says, what's the tangent of 30 degrees? You have to have it memorized. Does that make sense? So just start trying to, as you get these, at 30 degrees, memorize that that's the xy point. At 45 degrees, it's that xy point. At 60 degrees, it's that xy point. Does everybody see what I'm saying? Okay, now let's write in, just for kicks and giggles, the tangent of this, the tangent of this, the tangent of this. So the tangent would be this over this. We already simplified one. Can anyone tell me what we got? So I'm just going to write that on the side and know that that's my tangent. Root 3 over 3. So then that same distance right here's tangent will also be root 3 over 3. And then wouldn't it be a positive divided by a negative? So it'll just be negative. Now go to your other 30 degrees up. So this would be root 3 over 3. Tangent would be a negative and a positive would be a negative. And then right here, this is another 30 degrees in distance. So this one's tangent would be root 3 over 3. And that would be a negative and a negative. Wouldn't it be positive? Yes. Okay, so I just like to write in the tangent of each little piece myself. Just because we have sine and cosine, don't we? X, y are sine and cosine. So I like to have my tangent just sitting there as well. Does that make sense? So that it's quick when I start using it. So then what will the tangent be at this middle thing every time? 1. So you can go put in a 1. In the middle, 1. In the middle, 1. And then you'd say, okay, positive, positive is positive 1. Positive, negative is negative 1. Negative, negative is positive 1. And then positive, negative is negative 1. What would the tangent be at this? So you could do some math real quick. It'd be this divided by this. You get square root of 3. Who said that? Thanks. Yes, she did it for us. We get square root of 3 right here. Do you guys need me to do the math, or could you do the y divided by x? Okay. So this one's tangent's root 3. So then this one's tangent's root 3. But it's a negative and a positive, so it would be negative root 3. So down the 60 degrees, this is tangent's root 3. It's a negative and a negative, so it'll be positive. And this one's tangent right here is root 3, positive, negative. I just kind of write off to the side my tangents, just so when I start doing some math, it's really quick. Yes? Yeah, yep, yes, true. Yep. Okay, everybody, I want you to take a second and practice filling in a blank circle from start to end, seeing if you can find a pattern that will work for you. I don't care how you fill in a unit circle as long as you can do it correctly for the test. It says, evaluate the 6 trig functions at each real number. So it says, at theta of pi 6, locate pi 6 on your unit circle. It says, find the sine at pi 6. Well, sine is the y value, isn't it? So 1/2. Now watch what I would directly do then. I'd go right down to cosecant. Cosecant is that reciprocal answer. 2 over 1, so 2. Okay, good. Moving on. Then you'd say cosine is the x value at pi 6. So that's root 3 over 2. Go right down to secant, and that would be 2 over root 3, which would need to be rationalized. 2 root 3 over 3. Awesome. Go on to tangent. Tangent is the y divided by x at the 30 degrees. Haven't we kind of trying to memorize it? It was root 3 over 3, wasn't it? Root 3 over 3. And then down here, reciprocate it, and you would have 3 over root 3, which would rationalize to be 3 root 3s over 3, which would be root 3. Awesome. Okay, let's go to 0. It says at 0, locate 0. The point is 1, 0. I'll write it bigger. So sine is the y value, so we'd say 0. Now watch. Go right down to cosecant. Careful, because watch. Isn't 0 technically 0 divided by 1? So then cosecant would be 1 divided by 0, which is? Can we divide by 0, people? It's undefined. You can't find it. It's undefined, okay? Everybody gets that. Which makes sense. If you ever have an answer as 0 and you have to reciprocate it, the bottom will now be 0. It's going to be undefined. Okay, cosine at 0 is 1. Therefore, secant is? No, what's 1? 1 over 1. So secant is 1. Then tangent is the y divided by the x. 0 divided by 1, which is 0. Therefore, the cotangent must be undefined. Awesome. Okay, let's just keep going. Let's keep going. Try another one here with me. We'll just go quick. Let's just stick together because it's quicker. So it says at pi, find the sine. 0. Therefore, cosecant is undefined. Okay, you get the picture. And cosine is? Therefore, secant is? Negative 1, because that's negative 1 over 1, guys. If you reciprocate it, you get negative 1 again. Tangent is 0 divided by negative 1, which is 0. Therefore, cotangent must be undefined. Okay, good. Now look, negative pi thirds. So go up positive pi thirds in length. It's up here. So if you go negative pi thirds in length, won't that be right here? At 5 pi thirds. So then your sine is negative root 3 over 2. Therefore, cosecant would be 2 over negative 2 over root 3, which would rationalize to be negative 2 root 3s over 3. Cosine would be, therefore, secant is, tangent is, it's the further one down. Which one did that simplify to be? Root 3, and it's in this quadrant, so a positive and negative would be negative. Therefore, cotangent would be, this is over 1 technically, right? Yes. So it'd be 1 over, so negative 1 over root 3, which would rationalize to be negative root 3 over 3. Any questions on that? See, we like the unit circle. That was easy. This would be an easy test. Agreed? Okay. If you fill it out right. Yep. Okay, so now let's keep answering this. This says, what is the sine of negative 15 pi thirds? Now, isn't this saying, what is the y value? At negative 15 pi thirds. Well, what is negative 15 pi thirds? Negative 5 pi, isn't it? Now, I like to be in the positive. Unit circle is from 0 to 2 pi. So couldn't we do something to this to get to the same spot as negative 5 pi? Yeah, couldn't we add 2 pi and we'll be in the same spot? Because that's just going around the circle, and that's still negative, so shouldn't we add 2 pi maybe again? And then we're still negative, so add 2 pi again, and we get pi. You guys, negative 5 pi and pi are in the exact same position, coterminal angles. Do you guys see? Yes. So I literally can just go to pi. That is negative 5 pi, right there in that same position. And now what is the y value at pi? 0. So my answer is 0. Yeah, very easy. I just get right back on the unit circle if I'm ever off of it. Okay, let's do another one. Okay, what is the cosine of negative 90? That one's on the unit circle pretty easy. What is it? Cosine? 0, guys. Cosine's x, so go to negative 90 and the x value is 0. What is the sine at 225? Locate 225. It's the y value, so negative root 2 over 2. Okay, good. Any questions on that? Okay, next thing you need to write down is, let's talk about domain and range of sine and cosine. Super easy. Isn't it true? Here is my unit circle. Remember we had an XY chart a minute ago? Didn't I take and wrap the real number line around this? Can't I go around forever? So my domain must be all real numbers, or negative infinity to infinity. Right? I can go around forever, can't I? The real number line's wrapped around forever, both ways. Do you guys see? But now, what's my y values bouncing between? Y values? 1 and negative 1, aren't we? Aren't we getting input? Output always between 1 and negative 1. So our range is just negative 1 to 1 for sine and cosine. Now we just saw this rule. This is literally the rule we already know. Let's see if we can decipher what it's saying. It says sine at an angle will be equivalent to sine at an angle plus 2 pi. Just ignore the end for a minute. Is that true? Sine of any angle will be the same thing, will be equal to sine of that same angle plus 2 pi. Yeah, you guys see how this is, it makes sense, right? Look at this formula here. So, and then why is there an n? Because can't I add 2 pi as many times as I want? So it says sine at this angle will be the same as sine of that angle plus 2 pi. Plus 2 pi. Plus 2 pi. Does everybody see? Write that down. Okay. So now cosine, same idea. Cosine at any angle will be equivalent to cosine at that angle plus 2 pi. Plus 2 pi. The n is once again just n number of times. That is the idea of using coterminal angles to evaluate. So just in case in the future you see that, you're not like, what is that? That is literally the definition right here of a coterminal angle. What we were just using a second ago, you know? We were using this idea of coterminal angles to evaluate things easier. So we'll keep using that, a couple more examples here. We're winding down to the end of the lesson here. A couple more things. So if I said to you, find the cosine of 5 pi, I personally, let me hurry and plug in. I personally would get back to on the original unit circles so I don't have to go around so many times and figure out where that's at. So what would you do? I'd go backwards. You're fine. Minus 2 pi, still not quite there. Minus 2 pi, am I there? So cosine of 5 pi, guys, is equivalent, the same thing as cosine at pi, right? Yes. Okay, so go to pi, the cosine is the x value. My answer is equal to -1. Agreed? Okay, awesome. All right. Write this down, even and odd functions. Once you understand this, it's really straightforward, so everybody just start writing it down. An even function, cosine will be even, sine and tangent will be odd. And we'll talk about why in just a second. Now, I'm going to tell you, we learned even and odd functions in the very first unit of the year. So it's been a long time ago. It was like within literally the first couple lessons of the whole year. So it's been a long time since we've learned how to identify if a function is even, odd, or neither. But we're going to have only even and odd, not neither. So even and odd functions. So I'm going to let you write this down, and then I'm going to remind you how it works. But I'm not going to explain anything until you've written it down so you can actually understand what I'm saying. Okay, I'm going to start reminding you of how back in the day we determined if something was even, odd, or neither. Okay. So how we determined, if I said to you, is this even, odd, or neither, this is what we did. We took the original f of x, and to test if it's even, odd, or neither, we plugged in a negative x. We plugged in negative x and we simplified it down. Then we got an answer. Then what we did to see if it was even, odd, or neither is we looked at our answer and compared it to the original answer. If it's simplified to be the exact same thing as the original, it was considered even. So if we take and plug in negative x and we get back out the original f of x, it is considered even. That's what we saw. Now if it's odd, we took f of x, we plugged in a negative x, we simplified it down, and it came out to be odd if it's simplified to be -1 times the original function. That's what, by definition, made it odd. Does that kind of recall bells to some of you? Okay, so let's look at why cosine would be considered even using that idea. Now this, if you understand it, let's say on the test you forgot this, you could test and say, I don't remember, so I'm going to do this idea of testing and then see if it's even, odd, or neither. You would have to remember what even and odd means though. Okay, so let's take original cosine of pi fourths. What is cosine at pi fourths? The x value at pi fourths is √2/2. Now if I said to you, is cosine even, odd, or neither, don't we test by plugging in negative x? That's always what we do. So now I've done cosine of negative x. Do you guys see? Now I'm going to calculate it. What is the cosine at negative pi fourths? So I go down to negative pi fourths, boom. And what is the cosine at negative pi fourths? The x value is √2/2. So you're saying you plugged in negative x and got out the same as the original? That's by definition even. We know that if we take an odd function and we plug in negative x and it comes out to be negative 1 times the original, it's odd, right? So let's start at sine of pi fourths. Go to pi fourths, the sine is the y value, so I get root 2 over 2. Now to test if that's even, odd, or neither, now why am I using pi fourths? I randomly chose pi fourths. You could do any of these values. You guys see, I just chose pi fourths just because. Alright, so now I say to test this, I'm going to plug in negative pi fourths. So let's go to negative pi fourths, and that's right here. The sign at negative pi fourths is negative root 2 over 2. Well, isn't that negative 1 times the original? Making it off. Okay, so I do tangent at pi fourths. Now tangent is y over x, so we know that's something divided by itself is 1. To test if it's even, odd, or neither, I plugged in negative pi fourths. So I went to negative pi fourths, and then I get negative 1. So that's negative 1 times the original, making it odd. Awesome. Now we're going to use that idea to simplify things very quickly. Yes? Right. Yes, great question. All right. So now we're going to use that idea to simplify some very quickly here. So this says if, this is like on your homework. This is 38. So this one's in even. So it says if sine of negative t was 3 over 8, then what must have been sine of positive t? Negative 3/8. Isn't it true that if we take original sine of t and we plug in negative t, it's going to be, since it's odd, negative 1 times the original. So negative 1 times this would be 3/8. Do you guys see? Change the sign there. Well, if this is true, if sine of t is negative 3/8, then cosecant is the reciprocal of that, which would be negative 8/3. That easy. Okay, let's do another one. 40, it says, given that cosine of t is negative 3/4, what will happen if we do cosine of negative t? What answer will we get out? 3/4. The same thing. Isn't cosine even? Remember, if you plug in negative t, it should simplify to be the same thing as the original. So it should be negative 3/4. Therefore, our secant of negative t will just be the reciprocal of that. So that would be negative 4/3. Does that make sense? Everybody, how to use that? Okay, awesome. All right, this is the last slide of the lesson. Now understand, guys, if I ever say to you, evaluate sine of 2 pi thirds, evaluate cosecant of 2 pi thirds, evaluate cotangent of 1.5, if you can use the unit circle, you're going to use the unit circle because then you can give me an exact answer, not a decimal. Does everybody see that? So right here, could I use the unit circle? So I would, instead of a calculator. Right here, I would use the unit circle. But is this on our unit circle? No. So this one we'd have to use a calculator. We don't have a choice. Does that make sense? So I'm just showing you, though, how to type it into your calculator. Everybody go to your calculator. If I said to you, use your calculator to find sine of 2 pi thirds, notice we're inputting a radian. So you got to go to mode on your calculator, hit the mode button. It's right by the second key. Hit mode and go down and make sure your calculator's in radian mode. And then you can literally type in sine of 2, then hit pi divided by 3. It will only give you a decimal answer. Your calculator, not an exact answer. So 0.866. Does everybody see how to do that? If you have it in degree mode, it'll still calculate it. It'll just calculate it wrong. You got to make sure. Okay, now right here, cosecant at 2 pi thirds. Type it into your calculator. Well, cosecant isn't a button. So isn't cosecant 1 over sine? So you literally go 1 over sine of 2 pi thirds in your calculator. Good, 1.15. Okay, good. Let's just round there. So cotangent, what do we need to write? 1 over tangent in our calculator of 1.5. Now, guys, this is a radian. It didn't have a degree. This is a radian. So is this a radian? So is this. It's just remember, pi's already been multiplied in right here, right? So you would say now, you got what? Okay.
Yep.
Thank you. All right, now it says cosine of 30 degrees, use your calculator. Once again, if you can ever use your unit circle, that would give you an exact answer, which is better than a decimal answer, but because of the instructions, we're going to follow it. Go to mode, You have to change it to degree mode because you're inputting a degree now. And if you don't, it'll still calculate it. It will calculate it wrong. There's always that person on the test. Cosine of 30 degrees is, you're, I think, that one person on accident. But make sure you go to degrees. It's degrees now. Are you in degrees? I think you must have something going on because this should be 0.86.
Yeah, it was in radians and not degrees.
Yeah, so just make sure you're in the correct mode because it will calculate it just wrongly. Okay, so then secant would be 1 divided by cosine of 30, and then hit enter, and you get 1.15. If you're not getting this, you're not in the right mode. Those are degrees, so we need to be in degree mode.
I see.
Awesome. Any questions on that? Okay. That is the end of the lesson. Go ahead and start working on the homework.